Welcome back to the channel. For today's video, we're looking to find the sum of two variables when we're given a single equation that links both of them. Let's go ahead and begin. Looking at this equation, I can see that what we are trying to find, x plus y, is already contained within. So I guess from here, the most direct way to do it is to multiply 2 on both sides and then try to get rid of the square root by taking a square. But that is probably not the easiest way to go, so let's go ahead and find a shortcut. Let me first clean up what I have over here. And if you want to try to use a different method, let's try to do this. I'm going to let a to be equal to the square root of x minus 3. And also I'm going to let b to be equal to the square root of y plus 1. From here, if I take a squared, then that's equal to x minus 3. If I move 3 to the left hand side, I have a squared plus 3 equal to x. Likewise, I can do a b squared on the left hand side, which is equal to y plus 1. From here, b squared minus 1 will be equal to y. Keep these two in mind because these are what we are going to be using. What we're looking for is the sum of x and y. So let me go ahead and express x and y in terms of a and b. X plus y will be equal to a squared plus 3 plus b squared minus 1, which is also equal to a squared plus b squared plus 2. I'm going to make use of these three equations that I have established, and I'm going to substitute them back into the original equation. In other words, I'm going to express the original equation in terms of a and b. So what I have is a plus b is equals to half of a squared plus b squared plus 2. Let me copy this down properly so that we can continue to work on it. I have a plus b is equal to 1/2 of a squared plus b squared plus 2. From here, I'm just going to multiply 2 on both sides just to get rid of the 1/2. So now what I have is 2a plus 2b is equal to a squared plus b squared plus 2. Let's move everything to one side. So what I have now is a squared minus 2a plus b squared minus 2b plus 2 equals to 0. If you have watched some of the previous videos in this channel, you'll notice a technique where we sometimes just break apart a constant to suit us in terms of our factorization. So this is what we are going to do here. Instead of writing it as 2, I'm going to break it into 1 plus 1. From there, I'm going to slot each one into our individual quadratic expression here and here. So how does this look like? It's going to look like a squared minus 2a, let me change the color, plus 1 plus b squared minus 2b plus 1 equal to 0. In other words, I'm simply just breaking up the 2 and putting them into each of the brackets so that I can factorize each one of them. If you notice, each of the bracket can conveniently be factorized into a minus 1 square plus b minus 1 square equal to 0. From here, we have a way to work out the values of a and b. I apologize, that's a mistake from earlier. Let me correct it. It should be b squared minus 2b plus 1. From there, we can factorize that into b minus 1 square. So what I have now is a minus 1 square plus b minus 1 square equal to 0. What is the conclusion that we can draw from this? We know for any squared number, a minus 1 square has to be greater than or equal to 0. And likewise, b minus 1 square has to also be greater than or equal to 0. So the only conclusion that we can draw from this equation is a minus 1 equal to 0, a equal to 1, b minus 1 is also equal to 0, and b is equal to 1 as well. Going back to our earlier substitution, we said a is equal to the square root of x minus 3. And since a is equal to 1, x minus 3 will be equal to 1 square. So x will be equal to 1 square plus 3, which is equal to 4. And also, from our earlier substitution, we said b is equal to the square root of y plus 1. From there, y plus 1 is equal to 1 square, which is equal to 1. Y is equal to 0. In other words, when we work out the sum of x and y, we have x plus y equal to 4 plus 0, which is equal to 4. That's the final answer for today's question. I hope you enjoyed this video. Have a good day. Goodbye.